How many moles of ethane is required to produce 44 gram of CO2 after combustion? Let us first find in 44 gram of CO2 how many moles of CO2 are there, and therefore NCO2 is equal to mass divided by molar mass. Mass is given here 44 gram. Molar mass of CO2 is 44 gram per mole, because here it is 12 plus 2 times 16, that becomes 44, and that means 1 mole. So, the actual question is how many moles of ethane is required to produce 1 mole of CO2 after combustion. That is the actual question. So, let us write the equation. Ethane, we know that the molecular formula is CH3CH3. Combustion means burning with excess of oxygen. So, and that produces CO2 and water. We have 2 carbons on the reactant side. So, put 2 here, 6 hydrogens on the reactant side. So, put 3 here. So, now the carbon and the hydrogen are balanced. Oxygen, we have 7 oxygen atoms on the product side now. So, put 7 by 2 here. Multiply the entire equation with 2, so that we can avoid the fraction. So, that means 2 CH3, CH3, 7 O2, 4 CO2, 6 H2O. Now, the equation is completely balanced. Let us write the stoichiometric moles. So, here 1 by 2 N C2H6. So, whatever be the coefficient that is in front of the reactant or product, that comes in the denominator. So, that is how we write the stoichiometric moles. And here O2 is in excess. So, this is the excess reagent. Why? Because combustion means burning in excess of air. So, O2 is the excess reagent and it is the ethane molecules that is the limiting reagent here. So long as you have ethane, you will get CO2, and therefore, that stoichiometric moles you need to compare with the product, that is CO2 here. So, this is 1 by 4 NCO2. NCO2 we already determined it. Therefore, 1 by 2 NC2H6 is equal to 1 by 4 times 1 mole. And therefore, NC2H6 will be equal to 2 by 4 mole. Therefore, NC2H6 equal to 1 by 2 mole. So, we require half a mole of ethane to produce 1 mole of CO2. That is the correct answer.